Hello everyone. In this video, we are going to talk about adding cameras and vision sensors as well as lights in CoppeliaSim. So this is one of the scenes that I used earlier for a navigation algorithm called the Brightenberg. Here I have added a light source, a directional light source, a camera here you can see, and a vision sensor. And I have added these what we call floating views, okay? And I want to show you how to do that. And when we run the code, so this is like a top view, this is like a front view. This one here comes from that camera. This is the default camera, and when I run the code, the vision sensor will create a floating view here on the right side. Let me show you. There we go. Okay, so I want to show you how to do that in CoppeliaSim. Okay, first creating lights. So to create lights, all you need to do is to right click anywhere and say add and then say light. Okay, or you can do it from here. And there are three different types of lights. There is an omnidirectional, which basically gives lights to every point. There is no direction for it. There is a spotlight and there is a directional light. And these two are relatively close. Directional light, it's just the way that the light is spread. The shape of it is a little bit different. So this is an omnidirectional light, this is a spotlight, and this is a directional light. And you can see here that scene one is with ambient light only. Here we had a directional light, here we have a spotlight. So basically the area that they basically eliminate is a little bit different for each one of them, especially between the omnidirectional and the two others. So here I added this directional light, right? But again, let's say I want to add anything else, just right click, add light, and let's say add a spotlight. And there we go. Here you see there is a spotlight here that is added, and you can simply double click on it and you can create the setup, right? Or adjust it. So this is the spot exponent, right? This is the attenuation factor. This is the quadratic or linear ones. There are a bunch of parameters. You can change the size of this object. You can change the color of the light, right? So right now the color is kind of grayish. You can see here, but let's say I want to make the light, blue, for instance, right? So I just grab these two guys and bring them close to 0 and put this on this side. And now let's see. So here is the directional light, and let's go ahead and rotate this guy so we can see the effect of it. Let me pick on the right item here because it picked the wrong one. So okay, you can see the effect here. Yeah, you can see the blue color over there, right? If I zoom in, you can see the blue color, and you might say, what happened? Why is it yellow here? Because it's not just that color, it's also the color from this directional light as well. But you clearly can see that if I shine this guy to any specific direction, I can basically change the color of that part, right? If I properly shine it to, but the spotlight is not as strong as a directional light. This one has a lot more power to illuminate. And as you can see, the color of this one, I changed it to yellow, right? But feel free to change it to anything else that you like, okay? So this is a light, very simple. Now, what about the camera? For creating a camera, again, very simple. You right click and say add, and then you say camera. And there are two types: perspective, which is the one that most of the real life cameras see, and our eyes. The objects get smaller as they get away from you, or you can do orthogonal type, which do not depend on the distance, and you can see something like this. Okay, so this is an orthogonal view, but this is a perspective view, or this one is. So you can add any of them that you want. So let's see, for instance, I go ahead and add a camera here. There we go. You see this camera added here. And again, if I want, I can go ahead and I can orient this guy, right? So put it like there. And now if I want to add a view from this camera, all I want to do is right click here and then say I want to add, and then say I want to add a floating view. So this is a floating view. And now this floating view could be associated with this camera 1, right? So I can right click on this view and say view, and then say view selected or associated with this camera that I have already highlighted, right? And there we go. You see, this is the view for this camera. So just highlight your camera, add a floating view, right click and say view the associated camera, and that's all you see. Or if you want, you can say go ahead and show me the view selector, and it shows you all different views that you have, and you can pick which one of them to be shown on this floating view. There we go. Okay, so this is adding a camera and showing it on a floating view window. Good. So now that you learned about a camera and a light and how to add them, I want to talk about the vision sensor. So what is a vision sensor? So you might say camera is a vision sensor. It is. But in CoppeliaSim, there are 2 categories. So I need to talk a little bit about them for you. So let me bring it here. If you look at the help pages, you can see that the cameras and vision sensors are not exactly the same thing. A camera does not have any specific resolution. It adjusts to the view size, but a vision sensor has a resolution, and I'll show you that. A camera image is not typically what you can do image processing on directly. A vision sensor is what you can get the images of that, and you can do all sorts of processing on it, computer vision, image processing, and so on, which I'll show you in future videos. And so camera is just like a display only, but vision sensor, you can add more API commands to the script of it and get it to do a lot more for you. So it has the processing power. And for that reason, a camera is a faster device, vision sensor is a slower device. And camera can see all object types, vision sensor can only see shapes. Okay? And the biggest thing that you can see here is when you add these floating views and so on, to show the view for a camera on a floating view, as I said, is extremely simple. Right click and say what? Show the associated camera. Okay? But for a vision sensor, it's not just like that. So if you have a vision sensor and you add a floating view, right? And then click on this vision sensor and say, hey, show me this. Okay, so in this case, it does show you that. Why? Because I have already written the script for it. But it's really the script that you need to write in order to show you the image. And you can see that over here, you can see that it says, once a viewing object is associated with a view, the image will be displayed except for vision sensors. A vision sensor needs to generate its image content, and this can only happen when it uses the command, and you do it by a script here. Okay, and that's what I have done here. So this is the script, and I'm going to share this script with you under video description. But you can see that here I have to provide the name of my vision sensor, which I call it vision underscore sensor. Then you need to use this command pcall and pass to it the sim get object handle with the sensor name. Why would you do that? Why don't you directly use the sim get object handle and then pass to it the sensor? Why you pass the command and the sensor name to this command pcall? The good thing with this pcall is this pcall does not crash the code. This kind of acts like a try and catch. So if the code works, if this command works, then you're going to get your result. If not, the code is not going to crash. So this is another interesting thing here. And so you see, if the OK, which is the status, is good, and if H, which is the handle, is a non-zero number, then of course it is going to assign that handle to the sensor handle. And initially we are starting the sensor handle and the floating view handle as -1. What does -1 means in Lua? Means basically start them as invalid first until what? Until they are set. Now, so this part is for getting the handle of the sensor, the vision sensor. For the floating view, we use the command sim floating view add, and it gives the handle of that, but you need to provide it 4 pieces of information, or in this case 5 with an option. The first 2 are the X and Y position of it for the top left corner, and the next 2 numbers are the width and the height of it, and these are all normalized numbers. These are between 0 to 1. And this option 0 here means that this one is not any special basically window. It's just a simple floating window, and it's like the default mode. So once it creates this handle for you, now what would you do? You say, hey, go ahead and associate that sensor handle to this floating view handle and use option 0. What does option 0 means? Means this floating view is not interactive. It just shows the image, nothing else. Okay, so you connect them together, and now if everything is working, if it's not working, if this OK or H is 0, then just show an error message and say, hey, I could not find the sensor. Okay, don't crash, just show a message here in the message bar. And then what would you do in the sensing command? All you do is to call use the pcall command again, and pass to it basically the sensor handle and the vision to this sim vision sensor. So basically get the handle, and then once you do that, when your sensor handle is not -1, which means you correctly captured the sensor, this command here basically forces the basically vision sensor data to be sent to the floating view and to be shown on that. And this cleanup, what does this cleanup do? It says if basically once the simulation stops, when the simulation is over, go ahead and use the command floating view remove and pass it F handle. What does that mean? It means basically close or delete the floating view. So whenever the code stops, the floating view window will disappear. It will automatically close. This is the cleanup part. Okay, so this is your whole code, and you can clearly see that when I run the code. Right, this is the floating view. It is showing the content of this vision sensor, and as soon as I stop the code, guess what? It closes it. Okay, so this is how you add a vision sensor. The last thing I want to show you before I finish this video is you under modules and then go to tools and then run this command called color changer. So look, when I click on this, it opens up this window, and now it just needs me to click on any item. So right now I clicked on concrete block, so it is gonna change the color of concrete block. If I want, I can click on the sofa, right? And then, hey, it says which part of the sofa, A part or B part of it. Can click on any item. Let's again go back to this concrete block and click here. And very fast, I can go ahead and change the color of it. Look, there we go. So you don't need to go and double click on everything, go to the object, find the property of color and change it. You can just run this and it is going to do it very fast. And you can do other things too about it, but for now we just want to show you this option here, and when you're done you can stop it. But these are some basic display items that I wanted you to know about, and I'll show you further stuff in future videos. Thank you for your attention, and I'll see you in the next lecture. Thank you.